Download this code from codegive.com, link in the description below. OK, let's dive deep into the Python encode method for strings, drawing from the information and examples you find on W3Schools and expanding upon them for a comprehensive understanding. Understanding string encoding, the foundation. Before we jump into the encode method itself, it's crucial to grasp the underlying concepts of character encoding. Asterisk characters. Asterisk in computing, a character refers to a symbol, letter, digit, punctuation mark, or control code. Think of it as anything you can type on your keyboard or see displayed on a screen. Asterisk encoding. Asterisk computers work with numbers, not characters directly. A character encoding is a system that maps characters to numerical representations, code points, and defines how those numerical representations are stored as bytes in memory or on disk. Asterisk Unicode. Asterisk Unicode is a modern character encoding standard that aims to provide a unique code point for every character in every writing system of the world. UTF-8, UTF-16, and UTF-32 are different encodings that implement the Unicode standard. UTF-8 is the most popular encoding for the web and is often the default encoding in Python. Asterisk bytes. Asterisk bytes are the fundamental units of data storage in a computer. A byte is typically 8 bits. Encoding converts characters into a sequence of bytes. Why encoding matters? Encoding is essential for several reasons. 1. Storing text. Asterisk computers can't store text as is. They need to convert it into a numerical representation suitable for storage. 2. Transferring data. Asterisk when you send text data over a network, example email, web pages, both the sender and receiver need to agree on the same encoding to interpret the bytes correctly. If they don't, you'll get gibberish or errors. 3. Supporting different languages. Asterisk different languages have different character sets. An encoding like ASCII can only represent a limited set of characters, mainly English. Unicode-based encodings are necessary to handle a wider range of languages. The encode method, converting strings to bytes. The encode method is a built-in string method in Python that converts a string, which is a sequence of Unicode code points, into a sequence of bytes using a specified encoding. It essentially translates the characters into their byte representations. Syntax. Asterisk string, the string you want to encode. Asterisk encoding, optional, the name of the encoding you want to use. The default is UTF-8. Common encodings include asterisk UTF-8, a variable width encoding for Unicode. It's highly compatible and efficient for most use cases. Recommended. Asterisk ASCII, a limited encoding that only represents basic English characters, and some control characters. Suitable only if you know your string contains only ASCII characters. Asterisk Latin 1, also known as ISO 8859-1, an 8-bit encoding that can represent many Western European characters. Asterisk UTF-16, another Unicode encoding, typically using 16 bits per character. Asterisk UTF-32, a Unicode encoding that uses 32 bits per character. Asterisk errors, optional, specifies how to handle encoding errors, characters that cannot be represented in the chosen encoding. Possible values are asterisk strict, default, raises a Unicode encode error if an encoding error occurs. Asterisk ignore, ignores characters that cannot be encoded. Data loss may occur. Asterisk replace, replaces characters that cannot be encoded with a replacement character, usually. Asterisk XML replace, replaces characters that cannot be encoded with an XML character reference. Asterisk \replace, replaces characters that cannot be encoded with \escape sequences. Asterisk name replace, replaces characters that cannot be encoded with a named escape sequence, \n. Return value. The encode method returns a bytes object, which is an immutable sequence of bytes. Bytes objects are different from strings, they represent raw binary data. Code examples, with explanations. 1. Basic UTF-8 encoding, default. Explanation. Asterisk we create a simple string text. Asterisk we call encode, without specifying an encoding. This implicitly uses UTF-8. Asterisk the output be hello, world. Shows that we now have a bytes object. The B prefix indicates a byte literal. Asterisk type, encoded underscore text, confirms that the result is of type bytes. 2. Encoding with ASCII and handling errors. Output. Explanation. Asterisk the string text contains Chinese characters, which are outside the range of ASCII. Asterisk when we try to encode it with ASCII, a Unicode encode error is raised because ASCII cannot represent these characters. Asterisk the try, except block catches the error and prints an informative message. 3. Encoding with ASCII and ignoring errors. Explanation. Asterisk we use ASCII encoding, but this time we set errors equals ignore. Asterisk the Chinese characters are simply dropped, ignored, during encoding. Asterisk the resulting bytes object only contains the ASCII compatible characters. 4. Encoding with ASCII and replacing errors. Explanation. Asterisk we use ASCII encoding and set errors equals replace. Asterisk the Chinese characters are replaced with question marks. This indicates that these characters could not be encoded. 5. Encoding with Latin 1. Explanation. Asterisk Latin 1 is a single byte encoding that supports many Western European characters, including the E in cafe. Asterisk encoding with Latin 1 works without errors. Asterisk we can then decode the bytes object back into a string using the same Latin 1 encoding. 6. Using SML-charef replace. Explanation. The characters are replaced with XML character references. 7. Using \replace. Explanation. The characters are replaced with \escape sequences. 8. Using name replace. Explanation. The characters are replaced with named escape sequence. Decode method, the opposite of encode. It's vital to understand that the encode method has a counterpart, decode. The decode method takes a bytes object and converts it back into a string, using a specified encoding. It essentially reverses the process. Important considerations. Asterisk consistency. Asterisk always use the same encoding when encoding and decoding. If you encode with UTF-8, decode with UTF-8. Mismatched encodings will result in incorrect text. Asterisk choosing the right encoding. Asterisk the best encoding to use depends on the characters you need to represent. UTF-8 is generally the safest and most versatile choice for modern applications. Asterisk error handling. Asterisk be aware of potential encoding errors and handle them gracefully. Choose the errors parameter that best suits your application's needs. Ignoring errors can lead to data loss, while replacing them with placeholders may be more acceptable in some cases. Asterisk file I/O. Asterisk when reading from or writing to files, always specify the encoding in the open function. In summary, the encode method is a powerful tool for converting Python strings into bytes, which is essential for data storage, transmission, and handling different character sets. By understanding the fundamentals of character encoding, the syntax of encode, and the available options for error handling, you can confidently work with text data in Python and avoid encoding-related issues. Remember to use decode, to convert bytes back into strings when needed, and always strive for consistent encoding throughout your application.